welcome to Matrax channel. So in this video, you will learn about the geometric means. And let us start with the definition of geometric means. The geometric means are the terms between any two non-consecutive terms in a geometric sequence. So let's say, for example, a geometric sequence in general is written as a sub 1 followed by a sub 1 times r followed by a sub 1 times r raised to 2, then a sub 1 times r raised to 3, and so on. So let's say that the two non-consecutive numbers indicated in this geometric sequence are the a sub 1 right here and the a sub 1 times r raised to 3. Then you would notice that there are two terms found between those two indicated non-consecutive terms. And this would be our geometric means. And to further understand the idea relative to the definition of the geometric means, then let us have these examples. So here we would like to identify the geometric means between the indicated terms in the sequence. And here is our first question. What are the geometric means between the -6 and the -96 in this sequence? So here we would like to locate the -6 and the -96 first in the sequence, and we have those terms here and the other one here. Now, you may notice that there are three terms found between those two non-consecutive terms, and they are the geometric means, which happens to be the 12, -24, and +48. Now, for number 2, our question is, what are the geometric means between 15 and 405 in this sequence? So here we would like to locate first the +15 right here, while the other given number is 405 right here. And you will notice that there are actually two terms found between those two, and they are the geometric means. And now let us proceed with some basic problems involving the geometric means. And for our first problem, find the four geometric means between +2 and 486. Now, to illustrate the idea of such problem, then, let us write the first number given, which happens to be 2. And since we would like to find four geometric means, then we would like to insert four blank spaces first before writing the other given, which happens to be 486. And now you will notice that we have a total of 1, 2, 3, 4, 5, and 6 terms. We may have an assumption that the first given number 2 is the first term in the sequence, while the sixth term in the sequence is the other given, 486. So at this point, you have learned in our previous lesson about the application of the nth term of geometric sequence, which has the formula of a sub n is equal to a sub 1 times r raised to n minus 1. So if we would like to run a data sufficiency test first, before assuming that we could make use of such formula, then we may have our a sub 6 be the a sub n right here. So that means we will have a certain value that replaces the a sub n in this formula. And since we are given with the information about the first term or the a sub 1, then there will be a certain value that replaces this in our formula. So since we have made an assumption that our a sub 6 is the a sub n, then obviously this n right here also changes to 6. So now, you will notice that the resulting equation now only contains one unknown value, which happens to be the common ratio, R. So this suggests that we could also make use of this formula for us to find the common ratio in the problem. And now, since we would like to have the a sub n be a sub 6, which has the value of 486, and our first term has the given value of 2, so we merely have to substitute such value, and our r is unknown for the meantime, and since we have our n is 6, so this n also changes to 6. And we have obtained such equation after applying the substitution property. And now let us manipulate and simplify this resulting equation for our answer. So having this exponent first, we have 6 minus 1, which happens to be equal to 5. So here we would like to isolate the r. So that means we should eliminate this numerical coefficient first by applying the division property of equality. So it only tells us to divide both sides of the equal sign by a certain number. So let's say to eradicate the 2, here we should divide this side of the equal sign by 2. And the division property tells us to do the same thing on the other side of the equal sign. Doing so, we have this be equal to 1, and we are only left with r raised to 5, while this one gives us 243. Okay. Now, let us try to answer this equation this way. So there is another way to come up with an answer here, but I would like to have my answer or my solution this way. So here I would like to write an equivalent exponential expression with 243 that uses 5 as an exponent. So meaning we are only looking for a certain base for which, when raised to such exponent of 5, gives us the value of 243. So if you are already familiar with such exponential expression, then this would be very easy. But if you are not familiar yet, then you may apply the prime factorization or continuous division. Starting with 243, this number actually is divisible by 3. So let us start dividing 243 by 3. So here, it gives us 81. And now, let us do the same thing for 81. Dividing this by 3 gives us 27. By another 3, it gives us 9. And finally, by another 3, it gives us the quotient of 3. Now, you will notice that we have obtained same prime factors of 3. So, counting for the number of these same prime factors, we have 1, 2, 3, 4, and 5. So that means 243 could also be written as an exponential expression of 3 raised to 5. So that simply means that the number that we are looking for here is the 3. And since we have obtained such expression both on the left and the right hand side of the equal sign, to have such exponent of 5, then we can now simply concentrate on the common ratio which has the value of 3. So meaning we could try to disregard this first and just look at the number in our base. And that would be the value of your common ratio. Now, we use this common ratio for us to find the next successive terms after the first term too. And that is by multiplying the 3 with the preceding number. Doing so, if we multiply the 2 with 3, so it gives us the next number 6. And multiplying this again with 3 it gives us the next number, 18. So we merely have to repeat this process. And now the geometric means are 6, 18, 54, and 162. And now for our next question. So let us try to illustrate this first. Insert 5 geometric means between negative 3 and negative 192. So starting with our first number, negative 3, so we need to insert 5 geometric means. And the other given is negative 192. And again, we merely have to write all the important information in the problem by assuming the first number be our first term, a sub 1. And since we have a total of 1, 2, 3, 4, 5, 6, 7 terms, then the negative 192 is our seventh term, writing a sub 7 equals negative 192. So again, for our formula, we have a sub n, which is equal to a sub 1 times r raised to n minus 1. So let us substitute this value for our a sub n. And for our a sub 1, it has a given value of negative 3. So our common ratio is unknown, but here we have used a sub 7 for the a sub n. So your n changes to 7. So let us start with our exponent here. So r raised to 7 minus 1, which is equal to 6. And we merely have to apply the same procedure. So we would like to eradicate the negative 3, here being the numerical coefficient of r. So we must divide both sides of this equal sign by such number, negative 3. So giving us a 1. And now we are only left with r raised to 6, while on the other side we have a 64. So just to make things fast right here, again, we would like to write an exponential expression equivalent to 64 that uses the exponent of 6. So the base should be a 2 because 2 raised to 6 is equal to 64. Okay? So again, we could concentrate on our base, which happens to be the r, which has the value of positive 2. So we merely have to repeat the same procedure that we did before. So multiplying the common ratio of 2 to our preceding number to give us the next number. So doing so, we have a negative 6. And multiplying this again with positive 2, we have negative 12, followed by negative 24, and negative 48, and we have a negative 96. Now to check, we can multiply this again with positive 2, so the next number would be negative 192. So that means this will be the geometric means if the value of r is equal to 2. But there is actually another answer here. So you have already learned in my previous video that if you are given with a negative base being raised to an even exponent, it actually gives us a product of a positive number. Let's say, for example, we have a base of negative 2 being raised to 6. It actually gives us a value of 64, which is basically the same with our goal here. Okay? So this time, you will notice that negative 2 is another possible value for our common ratio. because the quantity of negative 2 being raised to the power of 6 is basically the same with r raised to 6. And if we try to ignore the common exponents of 6, then your r corresponds to negative 2. So that means negative 2 is another possible value for our common ratio here, for which there will be another set of geometric means given such case or condition. And that is when the negative 3, which happens to be our first term, is multiplied to this common ratio of negative 2, it gives us the next number of positive 6. So multiplying this with negative 2 gives us negative 12, and we merely have to repeat the same procedure. The next number would be 24, followed by negative 48, and followed by positive 96. Now, if you would like to check whether this negative 2 right here actually gives us the correct answer, then we may multiply this with 96. And that actually gives us the other given negative 192. So this actually justifies that the negative 2 is another possible value of the common ratio r.